Hey everyone, Geophysicist Stefan Burns here. There has been an explosion of volcanic activity across Earth just in the past few days. As many of you know, there has been a historic eruption in Ethiopia, Africa from Haile Gubi volcano, which is connected to the African superplume. That was on November 23rd. And in fact, that ash cloud, the carbon dioxide, the sulfur from that event has actually spread out all the way to East Asia. So that was a big volcanic eruption, but not the only one that has occurred. If you go through the timeline, we've been having eruptions in Kamchatka, Russia. We've also been having eruptions in the Americas. Kilauea volcano on the big island of Hawaii is still erupting, also Indonesia. So there's been a lot of activity. If we just go through that timeline, it really starts with Kashenikovsky volcano. It's been erupting since late July, early August after that magnitude 8.8 megaquake off the coast of Kamchatka. That's the first time that volcano has erupted in 600 years. That activity is ongoing. Then you also have Mount Semeru in Indonesia exploding pretty violently, creating a pyroclastic flow. There are boulders rolling down the hills, lahars. That was on the 19th of November. You have Kilauea volcano on the Big Island now with its 37th episode. That was yesterday, November 25th, less than 24 hours ago as I record this video. You have Volcan Perace having just erupted in Colombia. A couple days before that, we had Volcan Popocatépetl in Mexico. And you also on the Kamchatka Peninsula today have Besmiani volcano erupting. So there's been a ton of activity. You also have some earthquakes occurring near these volcanic zones, including like Japan. So there's been this lull in earthquake activity, but this increase in volcanic activity, which is quite interesting. And the big question that a lot of people are asking now is this just a initial warm-up phase for perhaps larger volcanic events? Because if you look through the historic geologic record, what we often see before large volcanic events, like those that create a volcanic winter, is that there's often buildup to that, not just from the main volcano that has that large eruption, but from multiple volcanoes nearby. There seems to be clustering of volcanic eruptions across Earth leading up to big events. So I'm not saying that there is a big volcanic winter type event coming, though it's certainly possible. We can't rule that out. They actually occur fairly frequently on the geologic time scale, every 100 years, every 200 years. We haven't had one for a while. So it could just be a pulse of volcanic activity that we're getting right now. It could also be something leading up to more. It's hard to say. The biggest volcanic eruption that we've had in the 21st century is from Tonga. That was in 2022. So this is also following after that G5 minus geomagnetic storm where we had a bunch of magnetic fluctuations across the globe. Interesting to know about the Haile Gubi volcanic eruption is that there were 4 X-class solar flares, and the light radiation from those explosions on the Earth-facing side of the sun, they only take 8.3 minutes to reach the sunlit side of the Earth. So you can look at what side of the Earth was hit by that light radiation. Every single time with those 4 X-class flares, it hit right over Africa, kind of effectively supercharging that African superplume less than 2 weeks before that historic eruption. So there's a lot of interesting things happening right now, and I'm going to break it down for you in this video. Let's go back to November 19th with the first big main event, and this is Mount Semeru in Indonesia in the Java Island region. And so we see the ash cloud from this. We also see the pyroclastic flow. This alert level for the volcano has been raised once again as a result of this latest development. And in general, Indonesia is a very active place volcanically. So there are volcanoes that are going off all the time in Indonesia. What we're looking at here with this video and the current trends right now are how they're stacking on top of each other. So if you just look at one of these eruptions, it's like, okay, that's normal. But you put all of them together, it starts to look a little unusual. It's not like the Earth doesn't go through these rhythms and earthquakes and volcanoes and more, but we are certainly on one of these ascending waves of volcanic activity right now. So this was November 19th, 2025, Mount Semeru in Indonesia, and the fallout from this is still being felt by the citizens and residents in this area. And here we have a great photo showing the ash cloud from that eruption at Haile Gubi volcano in Ethiopia. This is arguably the biggest eruption of the lot, though that eruption at Mount Sumeru was also quite large. This ash cloud has spread out all the way to Asia. So this was a big event, first time in 10,000 plus years. And it's not often that you get a volcano that's been dormant for so long to wake up. It was quite notable when Krishenikov volcano in the Kamchatka Peninsula woke up after 600 years of slumber. This has been 10,000 plus years. So this is a historic eruption in Ethiopia, showing that the African superplume is very active right now. This is a deep flow of energy from really deep in the earth, like near the core mantle boundary, going up through the mantle and expressing itself at the surface. And it's quite the coincidence that you get 4 X-class solar flares and the ionization events from that back to back to back in less than a week, just days before this eruption occurred. And then you also, immediately after those X-class flares, had that G5 geomagnetic storm. And so you can look at how the ionization of the ionosphere to a greater degree enhances the electric field potential, strengthening the global electric circuit and the atmospheric conductivity directly in that region, also inducing stronger telluric currents in the ground. These are electric currents in the ground. And you have what's known as the reverse piezoelectric effect. And that is effectively that when you have an electric current flowing through something that has a crystal structure, that induces mechanical deformations. It increases stress in that crystal lattice. So the piezoelectric effect is that if you apply stress to a crystal structure like a quartz crystal, it will generate electric signals as a result because free electrons pop out of the areas in there where they're able to hang out. The reverse piezoelectric effect is that the electric current applied to the crystal causes it to mechanically deform. That is a very solid explanation for what could be happening here with the 4 back-to-back ionization events from those 4 X-class flares, and then that follow-up geomagnetic storm, G5 minus, very, very strong. Those magnetic fluctuations inducing electric currents all across the earth, in the atmosphere, in the ground surface, all that could destabilize potentially magma chambers, which are under high temperature and pressure, and just a little shift could then create a domino effect and boom shakalaka, you get a big eruption. So I think that's very likely here. At least it's a very interesting, compelling hypothesis that's worthy of a lot more research because the connection between our sun, space weather, and the earth is much stronger than a lot of people think. And then shortly afterwards, we had a volcano erupt in Mexico. So this is Volcan Popocatépetl. And this footage was captured by a Diego. I'll link his YouTube channel in the video description, as well as the other filmmakers who captured some of these amazing sites that we're looking at. And we see that it is just smoking away at this moment in time. And this is a fairly active volcano, but in my mind, it's more the fact that it's combining in time with the others. It's very synchronistic. So it didn't do its thing 2 weeks later when everything was fairly quiet. It's a clustering of these events all at the same time, which perhaps is speaking to larger energetic changes that are unfolding deeper within the Earth as a result of those induced electromagnetic currents and changing force fields. And then shortly after that volcano erupted in Mexico, we had one erupt just further south in Colombia. So here we have Volcan Parace, and this is a pretty large volcano. This ash cloud did not rise up that high, only going up a kilometer, 2-3 kilometers, but you see that it is quite large. So this footage here is from the geologic surface of Colombia. They captured this from a service road, and we can clearly see that this volcano, just in the past few hours, has also done a big release of Earth energy. And then we also just had another eruption from Kilauea volcano on the big island of Hawaii on the 25th of November. This is the 37th episode from Kilauea volcano going back to December of 2024. It's been like clockwork over the past year, which isn't impossible for that to occur, but it is usually not so regular and frequent. Basically, the magma chamber here has been filling up and then discharging, filling up, discharging, showing that there's just a regular flow of energy coming out from that Hawaiian hotspot, which is one of the largest on the globe. And guys, check out how that magnitude 4.6 earthquake, which just struck the Big Island in Volcanoes National Park, occurred exactly at the end of episode 37 in that large discharge event, showing the clear connection in time between that volcanic eruption and earthquake activity below the surface related to the Hawaiian hotspot. So this was a big event, not as high with the magma plumes, the lava plumes, as the past few events where they've gone up to even 1,500 feet. Here they reached about 300 to 500 feet up, but clearly a big discharge of lava, as you see here on the Big Island of Hawaii. And that's not the only eruption that's occurred in the past 24 hours. We also have another big eruption from Kamchatka, Russia. Let's check it out. And another big eruption that has just occurred in the past 24 hours is that at Bezmiany volcano in Kamchatka, Russia. And this ash plume is visible from space, showing that this is also another big eruptive event. And so the footage here isn't that good. It's from a webcam. But it's good to at least see something here. We see it really getting stronger and stronger. I think this is snow is thawing right there. We can start to actually see the landscape, and we just see this ash and everything just pumping out of this volcano like crazy. So those are some of the volcanoes that have erupted. Maybe I'm missing one or two elsewhere around the globe. But these are the big events that have occurred just in the past week. And it really is quite notable that they're all clustering together. And if you take into account what occurred just a couple weeks prior with all the solar activity, it's pretty interesting. Guess what? Those sunspots are rotating back into view soon, and they've been super active on the far side of the sun. Let's check it out. And here we have our coronagraph view of the sun, which shows us these coronal mass ejections, which are launching off from the sun. It'll show you far side and also earth-facing events. And well, we haven't been seeing these explosions on the earth-facing side, and we know that the big sunspots right now on the sun as a whole are on the far side. So these are far side coronal mass ejections that are created from basically huge explosions on the sun. The main sunspot group right now on the sun is 15 Earths wide. So you take 15 Earths, stack them in a line. That's how big that sunspot is. It's soon going to be rotating into view on the Earth-facing side. It's been a very active sunspot group. There's others as well. And it's those sunspots that triggered that G5 minus geomagnetic storm back in early November of this year. So just a few weeks ago. And well, it looks like we are due for some more solar activity in just a few more days. So that could be big X-class flares that cause those ionization events, those radio blackouts on the sunlit side of the Earth. That's an immediate thing. 8.3 minutes later, those light photons reach Earth. It's a fairly transient effect. But doesn't mean there can't be longer term geologic changes that it triggers. And then there's also, if there is a big solar storm that comes inbound, that triggers a geomagnetic storm, and those can last for a while. And the geophysical changes that can result from that actually can go out not just days or weeks, but even months. The radiation belts will usually undergo some pretty dramatic changes in their structure and in their ion populations in the density zones that they occur at the L shell regions for months after a large event like a G4 or a G5 storm. The scale rating goes from 1 to 5. 5 is an extreme storm, and so we had a G5 minus storm. We were nearly at that G5 level. So we've been having tons of solar activity on the far side, soon to be Earth-facing, tons of volcanic activity. Maybe more volcanoes are going to erupt, and perhaps this is even just the beginning of a larger wave of activity. That is what we do see in the historic geologic record. That is often what happens. So we hope that's not the case, but it is good to be prepared for that. So having a survival plan in place is a good idea. It doesn't matter where you live, whether it's a volcano risk area, earthquake risk area, a weather risk area like cyclones and more, blizzards. You ideally would have 3 days of food on hand, 3 days of clean water, and a hand crank radio at a minimum, but I would recommend more than that. So that's something for you to think about. We have Thanksgiving tomorrow in the United States, so happy Thanksgiving to everyone that's watching. Again, I've been your host, Stefan Burns. Thank you all so much for watching. Smash that thumbs up button if you'd like to see more content like this. We cover what's happening with the Earth energetically by looking at geologic events like earthquakes, volcanic eruptions, geomagnetic storms, weather events, but also we look at the sun, solar activity, space weather, planetary resonances and alignments. We got a big planetary alignment coming up beginning of January 2026 involving Jupiter, the Earth, Sun, Mercury, Venus, and Mars. Very rare, even on like a century-long time scale. So I'll keep you up to date on that. And we even go beyond looking at cosmic and interstellar forces. So if you like the sound of that, then please subscribe. Wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.